Very happy Monday. This is Mr. Powie, and today we are going to be talking about one type of problem in our DeltaMath for the week. This is going to be Monday's problems, the parabola features. I hope you all are doing well, being at home, being safe, keeping busy, hopefully learning some math as you go. But this video is about one particular kind of math problem, so let's jump straight into it. If you do not have a notebook out or a piece of paper, I strongly encourage you to get one of those out right now so you can take some of these notes or do some of these problems along with me, which means you'll have them when you go back and do your own DeltaMath problems later. So let's dive right in. Monday, parabola features. So Monday. Parabola features. Now, I know this set of problems is going to ask you to do a particular kind of analysis on a number of different features. So I'm going to take a minute and I'm going to set up all the things I know we need to talk about in this video. So one of the things we need to talk about are this problem, the X intercepts. But instead of doing this problem right away, I'm just going to write down some of the other things I know we're going to need. So another problem they're going to ask us about are the roots. When I say problem, I should say features. Another feature they're going to ask us about are the roots. They're also going to ask us about the Y-intercepts. And you will also be asked about the vertex. And the last thing that will come up is a question about the axis of symmetry. So I'm just setting this all up right now. So when I go through these problems one by one, I'll have them already up and available for us to go through. So let's read this first problem. Using the graph, determine the coordinates of the x-intercepts of the parabola. Cool, x-intercepts. So x-intercepts are where the parabola crosses the x-axis. So where the parabola crosses the x-axis. Right. And hopefully, right, the language makes sense. X-intercepts, x-axis, but I'm going to underline x-axis because it's kind of the big idea here. And then I'm going to sketch this parabola. And I'm not going to do like a perfect job or anything. I'm not going for a precise drawing. I just want to sketch something so I can take some notes. Parabola like there. So the x-intercepts are where we cross the x-axis. The x-axis is right here. X-axis. And so the x-intercepts are this point, and in this case, that point right there. So our x-intercepts are going to be 2 points. And now let's get precise. So when I'm looking over here, I'm counting. It looks like this point is at -2 on the x-axis, and this point is at 4 on the x-axis. And when I say that, though, remember, points need an x value and a y value. So when I look at this point, the x value is -2, and the y value, because it's right on the x-axis, we know that the y value will be 0. And the other one, 1, 2, 3, 4. So the x value is 4. And again, the y value is 0. And this is important enough that I'm going to underline it, right? When we talk about x-intercepts, the y value has to be right there, right on that 0. Okay, so answer type. Answer type, 2 points. And the points are -2, 0, and 4, oops, not 40, 4, 0. All right, let's check it out. Submit. And a green check mark. Feels good. So that's X intercepts taken care of. Okay, next problem. There's another X intercepts problem. Okay, so we're gonna have to give up on this one. Yes, and go to the next one. Y-intercept, perfect. Okay, using the graph, determine the coordinate of the y-intercept of the parabola. So the y-intercept is where the parabola crosses the y-axis. And hopefully, like, that should feel good, right? Math is kind of, we're naming these things in math kind of consistently. X-intercepts cross the x-axis, and y-intercepts cross the y-axis. So let me sketch this parabola also. And when I'm sketching, this is not a precision drawing. This is just a sketch so we can identify where we're looking on the graph. It's not a bad looking parabola. Nice. So the y-axis is down here. Or not down here, it's this vertical axis here. And so the parabola crosses it at this point right there. So the y-intercept is going to be 1 point. And now I'm being specific. So going down, -1, -2, -3, -4, -5. But since I went down 5, since I went down to -5, that's the y value, right? The x value at that point is going to be 0 because I'm not going left or right. I'm just going straight down. But let me repeat that, right? For y-intercepts, the x value should always be 0. So answer type is 1 point. The x value is 0, but the y value is -5. Submit. Green check mark, feels good. Okay, so y-intercepts, check. Next problem. Vertex, perfect. Okay, so the vertex is I would say it's like the middle point of the parabola. Middle point. And this is not precision language either, because when we talk about the vertex, we're going to talk about the vertex in lots of different ways, depending on the style of parabola we're looking at, right? In this case, in this example, when a parabola looks like this, the vertex is at the bottom of that parabola. But you guys have seen examples of parabolas that maybe go the other way, where the vertex is at the top of the parabola. And the way we talk about the vertex, the way we talk about either being at the top or at the bottom, these are all good things. And I want you to keep thinking about this because the vertex is this really key idea when we talk about a parabola. So let me sketch this again. And again, I'm just sketching, right? I'm not trying to make a perfect drawing. This is not a precision drawing. This is just to help us think about where to look for the vertex. So in this parabola, that middle point is right there. That's our vertex. So our vertex is 1 point. Right, 1 point. And now we're going to be precise. So this 1 point, I'm counting, looks like it has an x value of 3. And if I look over here, it has a y value of -1. X value of 3, y value of negative 1. Answer type 1 point. 3, negative, oops, 1 negative, negative 1. Remember, it's always x comma y. Submit. Yes. Green check mark. Feels good. There we go. All right, vertex down. 2 more to go. Next problem. Roots. Hey, we're getting lucky. I didn't have to go through any more skipped or giving up examples. So roots. Okay, here's the thing about roots. Roots are the same place, are in the same place as the x-intercepts. So since we've already done x-intercepts, everything I said about that is the same for the roots. Hooray! This is great. So I'm going to say the same thing. The roots are where the parabola crosses the x-axis as well, right? Same place. And if you're thinking to yourself, well then, why do we call them two different things? Good, keep thinking about that. Always question the man. but seriously, as we go through parabolas, this is a question that should keep coming up. Why do we use different names for these things? And I think there are reasons. Oops, let me shift over a little bit so you can see there. I think there are reasons, but they're not immediately obvious, and they're certainly not obvious just when we look at a parabola. So keep this question in the back of your mind, right? Why do we call x-intercepts and roots, or why do we call x-intercepts roots, or why do we call roots x-intercepts if we're just going to be doing the same thing? And it's a good question. I'm not going to answer it right now, but I am going to ask you to keep thinking about it as we go through. So I'm going to sketch our parabola. And like I said, the roots and the x-intercepts are in the same place. So the roots, we will look here and here for the roots. So the roots are also 2 points. And now let's be precise. So 1 point is all the way over here, and the other point is right there. So 2 points. To get to this point, this looks like it's at negative 8. But remember, negative 8, comma 0. And this one looks like it's at negative 2, comma 0. Let me underline the zeros again because they do matter, right? Zeros. When the y value is 0, that's where we find our roots, and that's where we find our x-intercepts. So this answer type is 2 points because there's 2 of those dots, 2 of those x-intercepts. So negative 8, comma 0, and negative 2, comma 0. Submit. Yeah, green check mark. Feels good. Okay. All right, one more example, axis of symmetry. Let's see if we can hunt one of those down. Nope, Y-intercept example. Quick, check yourself. Using this graph, determine the coordinate of the Y-intercept. Can you point to the Y-intercept on this? If you can, good. If you can't, I'd say pause the video, check your notes, and come back when you can. Okay, so the Y-intercept is right here, negative 5. Good. I'm just going to keep scrolling through. Vertex, we already did the vertex. Same question. Can you point to the vertex really quickly? This is a good quiz yourself as we go, right? It's right here. Good. Give up. I'm still hunting for an axis of symmetry problem. Roots. Can you find the roots? Here and here. Right? Good. Next problem, Y-intercept, no. Oh my gosh, this is getting lame. I just want to do an axis of symmetry. Y-intercept, vertex, X-intercepts, Y-intercepts, never lucky. This is like playing a really boring game of math bingo. X-intercepts, X-intercepts, Y-intercept. I know they're out here. Vertex, axis of symmetry. Hey, okay, there we go. Using the graph, determine the equation of the axis of symmetry. Okay, so symmetry. Symmetry is a word we were introduced to last week, but symmetry is when something is the same on like two different sides, right? So people's faces are not perfectly symmetric, but they're kind of symmetric because one side of the face kind of looks the same as the other side of the face. Parabolas, we say, are symmetric because one side of the parabola looks like the other side of the parabola, right? So people often say symmetry means that the two sides are like mirrored or reflected. Okay. And so when we say the axis of symmetry, we're saying that the parabola is reflected across like a mirror, like a vertical mirrored surface where there's the left side and then there's the right side over here. So let me sketch our example. And again, I'm just doing a sketch. Doesn't have to be perfect. That one's pretty good. So the mirrored part of the parabola is like this vertical mirror, or this vertical line here. So let me use my Oakland Public Library card straight edge. So in this case, the word axis of symmetry you might think of as line of symmetry, right? The axis of symmetry is this line that shows you where the two halves of the parabola are kind of like folded. If you folded it, right, they would be on top of each other. So the thing to remember, if you want to talk about a vertical line, it's not a point, right? We're not saying that it's a point of symmetry. We're saying it's an entire line of symmetry. So, and that line is along the x value of wherever that line is. So when we talk about the axis of symmetry, we say it's a line or a vertical, let's say a vertical line. A vertical line through the middle of the parabola. A vertical line through the middle of the parabola. So when we write the axis of symmetry, it's always going to be an equation. And it's an equation because that axis of symmetry is going to be whatever x is equal to. So let me put that over here as well. For the axis of symmetry, it will always be x equal to, and then like something over here, right? Always be x equal to something. So in this case, now let's get precise. So in this case, the middle of the parabola is when x is equal to -4, right? This is the vertex. But in general, this whole thing is at x equals -4. Equals -4. And this is our equation, right? It's an equation because there's an equal sign. So let's do that. One equation. So just so you can see it, if you forget to do the x equals part and you just type in -4 and you submit the answer, yes, your answer is not correct, try to find your mistake. So this is not a very helpful hint on where the mistake is in this situation, though. I know what the mistake is because I did it on purpose. But this is another example of like, I think you probably are doing the right thing in terms of what you're thinking about and what you're looking at. The trick is the notation. When we talk about an axis of symmetry, that vertical line, you have to say x, oops, capital, x is equal to that -4. So now if we submit the answer, yes, check mark, green check mark, feels good. Okay. So that's it. These are the 5 key features of the parabola that DeltaMath is testing us on in this particular problem set. If you have any questions, please feel free to check in with me on Google Classroom or on email, or check into the live stream later today to get any other questions answered. But until then, please remember to be safe, be sane, and be kind to yourself and to each other. Take care, everybody. Bye-bye.